Hello everyone. I'm a bit busy right now with the final tweaks for releasing my game on Steam and writing a new book about making games in the Godot Engine, so I didn't manage to come up with a new shader tutorial. Instead, this time I'd like to show how a 2D shader can be used in a 3D scene, which can have plenty of applications in 3D games. So let's get started. So I've got the Godot open, specifically the project list panel, where we'll create a new project. Let's call it test3D and save it into a suitable folder. So I'm clicking create and calling it test3D. And let's browse for the folder. I think it's right here in Godot. Very well, select current folder, perfect. And the name, test3D, forward plus, let's click create. So the project is opening, and once it's open, I'll right click the root folder and create a new scene. The scene would be a 3D scene, and let's call it main tscn. Clicking OK, and in the scene panel, let's right click the root node, add child node, and find sprite 3D. Okay. I think that one is quite suitable for this purpose. We could achieve a similar result with a quad mesh, and actually we will do it in the later part of this tutorial. But now let's work with Sprite 3D. Before tweaking these node parameters, let's add the shader we'll be using. I have a folder open here with my Godot shader pack project, where we'll find a shader of a type canvas item. So opening shaders, clicking canvas item, and I think I have selected the one called hexagon grid. Yeah, let's drag it to the project, and here it is. I think this one is quite suitable, since I actually use it this way in one of my other games, and we even saw it in action at the beginning of the video. So it is here and it is ready. Let's get back to Sprite 3D node. In the inspector, we can see that we need to set the texture property, which is where we'll display this shader. But how do we do that, given it's a 3D element, while a canvas item shader only works on a 2D material? We'll solve it similarly to the tutorial where we handled the opposite problem, adding a 3D object to a 2D scene. Our solution is sub-viewport. So I better save the scene, and now once again let's right click the root node and add a child node of the type sub-viewport. I think it is actually right here. Very well. A sub-viewport is invisible by itself, so we can create content inside it for display on the Sprite 3D without that content interfering in the scene. Let's right click the sub-viewport and add a child node of colorrect. Colorrect? Yeah, the same colorrect we use in every tutorial about a 2D shader. So let's switch back to sub-viewport, and in the inspector we can see a preview of what it displays, and in the top left corner we see our colorrect. It's so small because by default it's 40 by 40 pixels, while the sub-viewport is set to 512 by 512. So let's scale the colorrect to the same dimensions, and now same dimensions. Where is it? Here. So by 5, and now if we click back and wait, yeah, now it covers the whole sub-viewport. Let's get back to colorrect, where we'll use the same setup as in previous tutorials. So I'll scroll down to the material section, open it, and add a new shader material to the material property. Click it, and let's drag our shader file into the shader property. And right away we can see the shader is working as expected. Let's save again using Ctrl S. So now, if we switch to sub-viewport and wait, yeah, it is already here. So it is updated with the current version of Colorect. If for some reason it doesn't show up, just try to open scene and reload saved scene, or do some movement with the mouse or change some parameters, and it should definitely reflect it. Okay, great. Now it's time to use this texture in 3D. Let's switch to 3D editor and select the sprite 3D node. And in the inspector, let's create a new texture, and it would be the viewport texture. This texture type needs special content, so Godot pops up a dialog where we choose our sub-viewport. Okay, and here we go. Here's the result. We can rotate the camera and see that our 2D shader is still nicely mapped onto a plane in 3D space. Notice that the shader is visible on both sides of the object. That's the difference between Sprite 3D and Quad Mesh. Let's demonstrate. So I'll go back to the scene panel and again right-click on the root node and add, and this time it would be Mesh Instance 3D. Okay, in the inspector, let's set the mesh to a new Quad Mesh and click it, and now we need to add a new material, and this time it will be a standard material 3D, because when we click it again, we scroll down to the albedo section, and here is the texture property again. So we can simply try to assign a new viewport texture. Okay, so Godot asks for something. Of course, we need to make the resource local to scene. And we need to apply that to the material, not the whole object, since the material contains the viewport texture. So let's scroll down to the resource section, expand it, and click local to scene. Now, if I go back to albedo and try to assign a new viewport texture again, it should work. Okay, and I think we should move this quad mesh a little bit on the x-axis so it doesn't interfere with the sprite 3D object. All right, nothing there yet, but of course, if we click this, we now have a new property, a viewport path. Let's click assign the same sub-viewport, and here we go. It's not too visible, so let's go up and change the dimensions of this quad mesh, for instance, 5 by 5 meters. Very well. Now we have both of them side by side. Notice the difference. The Mesh Instance 3D, the left one, is affected by the environment and light sources. So it appears in slightly dimmer colors, while Sprite 3D glows with constant brightness. This is easier to click to see if I click the 3 dots over there, and I think I should just move it down there so it's better observable. And now let's change the sky energy. So going down to black, nothing is visible at the left part. I'm going up. Now it's illuminated. So yeah, it's definitely, it works this way. Okay, and of course, if I rotate the camera, we can see that the quad mesh is one-sided. Nothing is there from this side. And if I scroll down and click, where is it here? Flip faces. Now it's switched. So nothing from the front side and the shader from the back side. Let's revert it. Okay, but we are not limited to a single plane, of course. If we change the mesh property, up, and this one, to something like, for example, box mesh, we can see how it will be mapped to the box. And of course, we need to set it up again. So I am adding a new material, standard material 3D, clicking it, and in the albedo, setting up the new viewport. Of course, again, this is a new material, so it's not local to scene yet. Clicking here, and texture, new viewport texture, click and assign sub-viewport, and here we go. It's on the box, on the cube. And of course, we could use any 3D object. Very well. So, how about a practical example? Here's a prototype of a game I started this year but haven't finished it yet, though I definitely intend to continue with it. You'll see the hexagon grid used as a screensaver on a monitor in the hero's office, and also a digital alarm clock next to the bed, which is another shader we created earlier. So let's start the game. Here it starts, and here it is. Okay, so this is the hexagon grid, as I mentioned. This is actually a menu screen, but it displays the scene from the real world, and the camera is slowly tilting, so it definitely has its 3D feel. Let's start the game, and now we can see it right here. This is the first one, and if I go to the bed and just tilt the camera a little bit, you can see at the bottom left corner the digital clock. Okay, it's a bit tricky to show the clock properly here because I haven't implemented lowering the camera yet, but hopefully it's at least somewhat visible. And as I said, this is a prototype that will undergo plenty of changes and improvements. So let's just exit the game, and this is it. Thank you very much for watching. As we can see, it's not difficult at all to display a 2D shader in a 3D environment, as long as we don't have extreme requirements and primarily want to use them on flat or slightly curved surfaces. To display them on a sphere, for example, we probably need to solve issues with image distortion and the poles and other details, which I won't be covering this time. This sub-viewport approach has many other applications. For example, instead of a color act, we could insert the output from another camera recording another part of the scene, which could be then used to make, say, a monitor in our game that shows the feed from a security camera. I think I actually plan to add something like that to my own game. So once again, thank you for watching, take care, good luck with your game projects, and I'll see you in the next video.